Hello, and welcome to this new lesson of your AI Solution Architect training. In the previous lesson, you learned what prompt engineering is. But one question remains. How do these artificial intelligences really work? ChatGPT, Claude, Gemini? These tools seem magical. You type a question and presto, an answer appears. But it's not magic, it's science. Today, we're going to open the hood and understand what's hidden behind it. We're going to go up the chain, from general artificial intelligence to LLMs. By the end, you'll know not only what an LLM is, but also why some prompts cost more and how to choose the right model. Let's start at the beginning. What is artificial intelligence? It's the ability of a machine to imitate human intelligent behaviors. Learning, reasoning, perception, language understanding. In simple terms, creating machines that can think and act intelligently. Note the think on think. Machines don't think like we do. They simulate intelligent behaviors. AI is everywhere. When you say, "Hey Siri," that's AI. When Netflix recommends a series, that's AI. When Google Maps calculates your route, that's AI. There are two categories. Narrow AI, specialized in a task like chess or translation. That's what we have today. General AI, capable of learning everything like a human, is still science fiction. Finally, two approaches exist. The symbolic approach, rules, and the connectionist approach, neural networks. It's the latter that dominates today and gave birth to LLMs. Machine learning, or automated learning, is a branch of AI where machines learn from data without being explicitly programmed for each case. The principle is simple but revolutionary. Instead of telling the machine, "If A, then B," you show it thousands of examples, and the algorithm discovers the patterns itself. Let's take the example of a spam filter. In classic programming, you'd have to write thousands of rules. It's endless. With machine learning, you give it 10,000 classified emails, and it learns on its own. There are three types of learning in machine learning: supervised, examples with answers; unsupervised, finding patterns without answers; and reinforcement, learning by trial and error, like in video games. Deep learning, or deep learning, uses artificial neural networks with multiple layers. It's this deep that gives it its name. Multiple successive processing layers. Imagine recognizing a face. The first layer detects the outlines. The second, the eyes, the nose. The third, the expressions. And the final one recognizes the person. Each layer extracts increasingly abstract features. Why does deep learning dominate? Because it outperforms other methods on complex tasks. It improves with more data, and thanks to the power of modern graphics cards. Deep learning is behind all recent breakthroughs: image recognition, machine translation, self-driving cars, and of course, content generation like text and images. We're now approaching the heart of our subject, NLP, natural language processing, or traitement du langage naturel in French. NLP is the field of AI that allows machines to understand, interpret, and generate human language. It's the bridge between humans and machines, using our most natural communication tool, words. Human language is incredibly complex, and that's what makes NLP so difficult. Ambiguity? The same sentence can have multiple meanings. Context. The same sentence can mean different things depending on the situation. Idioms, expressions that aren't understood literally. And sarcasm, where the meaning is the opposite of the words used. Despite these challenges, NLP has enabled spectacular breakthroughs. Instant translation, customer review analysis, automatic article summarization, info extraction, automated conversation with customers, and of course, text generation. And that's where LLMs come in. Here we go. Large language models, LLMs, are the culmination of everything we've just seen. It's the top of the pyramid. A large language model is a deep learning model, specialized in NLP, trained on massive amounts of text and capable of understanding and generating natural language. Step 1. Massive training. These models are fed with billions of pages of text. The model analyzes all that and learns language patterns. The basic principle is surprisingly simple. Predict the most likely word that comes next. The cat climbed onto the model calculates the probabilities and chooses the most likely one. The secret of modern LLMs is the transformer architecture. Its key innovation, the attention mechanism. The model can look at all the words in a text at once and understand their relationships. 3 key features: size, parameters, context window, amount of text visible at once, and emergent capabilities, reasoning, creativity. Understanding that LLMs are pattern predictors changes everything. They excel at text generation but don't really understand and have no consciousness. They can hallucinate. This understanding allows you to formulate more effective prompts, understand their strengths and limits, and optimize your interactions. Let's take a look at the main players in the market. It's important because as an AI solution architect, you'll need to know which model to choose based on your needs. OpenAI with GPT-4 remains the benchmark. Anthropic with Claude excels in writing and context. Google Gemini is multimodal. Meta Llama is open source. And Mistral AI offers excellent value for money. Let's recap the hierarchy: artificial intelligence, machine learning, deep learning, NLP, and finally, LLMs. Key points to remember. LLMs are pattern predictors, not thinkers. They predict the next word. The context window is limited. They can hallucinate. Each model has its strengths. You now have a solid understanding of LLMs. In the next lesson, we'll dive into the basic techniques of prompt engineering. Thank you for following this lesson. See you very soon.